Hello guys, welcome back after a week. I hope everyone is okay after a hurricane, especially here in Florida. Just like we need to continue. I'm sorry, yes, I'll try to be as fast as possible because we're a little bit behind. I mentioned it last week, but just as a reminder. And don't forget that if you don't understand something, you can always send me an email, text me through Discord. I'm here to help you. So basically, now question 38: Quadrilateral LMNO has vertices. Which statement about the quadrilateral are true? Select two that apply. So basically, we need to draw our quadrilateral, and we need to select two statements that are true. Now, I'll do. So -3 comma 2 is going to be here. This is L. 2 comma 1, 2 comma 1, and 3 comma -4, so 3, -4. This is N. And now -2 comma -3. This is O. Now our quadrilateral looks something like this. Wait, help. Okay, and this. So first, let's see if the sides are equal. And if we do this, I'm going to count 1, 2, 3, 4, 5. This is 5. And 1, this is 1. Now here, 1, 2, 3, 4, 5, and 1, 5, and 1, 1, 2, 3, 4, 5, 1, so 5 and 1 again, and 1, 2, 3, 4, 5, 1, so this is 1, this is 5. So as you can see, all the sides are equal to each other. And now, as you also can see, you see that the this line has exact same slope as this line, so this and this one has the same slope. I'll put it in another color. Um, that has the same slope because the rise is going to be 5 in this. Wait, let me use the same color. So this is going to be 5 over room, which is 1. Since it's going down, it's going to be -5 over 1 over 1. And here is the same 5 over room 5 over 1, and it's going down, so it's negative. So they have the same slope. And for this one, it's going to be 1 over 5, so like rise over room. So this is negative because it's going down, and in this case, it's going to be rise over room, which is 1 over 5, negative because it's going down, so they have the same slope. Based on this, also they are on this line and this line, so this and this, these two lines are not perpendicular because for a line to be perpendicular, as I mentioned before, they need to be up like reciprocal as low as it is here, but they also need to be opposite. So this line to be perpendicular to this one will need to be 1 over 5 positive instead of negative. Or this one will need to be 5 positive instead of negative. So basically, so this is not a right angle because they are not perpendicular. So L, M, and O cannot be a square since they don't have like a 90 degrees angle here. Now rhombus. So as you can see, the four sides are equal, and that's basically a requirement for it to be a rhombus. So yes, we can say that quadrilateral LMNO is a rhombus because the four sides are equal. Now, is it a rectangle? The answer is no, because as we explained it before, um, this angle is not a triangle, so it's not 90 degrees, which is the requirement for a rectangle. One of the requirements. Now, is it a parallelogram? Well, we saw the four sides, like the opposite sides are both parallel to each other. So yes, we can say it is a parallelogram. Now, they just say the select two that apply, so we don't need to say A. But basically, if we want to see, we can search. I think I know, and I will say it is true, but I just want to make sure and search geometry kite properties. Okay, basically, the property for a kite is that the diagonals intersect and form a right angle, and as we can see here, they do, so this will also be true. And now I explain why, just in case you didn't see it like right away. Did you say select two? So you only need to select two. I just want to show you all of the properties because as you see, the slope of this one is going to be 1. Positive is just rise and room, rise and room, rise, room. So it's basically 1. But you can also say 1, 2, 3, 4, and 1, 2, 3, 4, which is 1 over 4. Like this, which is 4 over 4, which is only 1, and it's positive because it's going up. And in this case, it's going to be 1, 2, 1, 2, 1, 2, 2. So this was positive 1, and as you see here, it is also 1, but this is going down, so it is negative 1, and they are opposite and reciprocal because 1 over 1, the reciprocal is 1 over 1, so it doesn't matter. And that's the reason they are perpendicular, so they form a 90-degree angle. Yeah, that's the reason these three are true. But you only need to select two. Now, this another one. Negative. Okay. Okay. For this case, I will need to make every square be 2. So I have the space to draw it. Great. Alright, perfect. Now, this is going to be 2, 4, 6, and 8. 2, 4, 6, 2, 4, 6, 8. Oops. 2, 6, 2, 4, 6, 8, 2, 4, 6. Now, E is negative 7 comma 3, which is going to be something over here. This is E. F is negative 4 comma 6, so this is F. 5 comma negative 3 is going to be over here. This is G. Oops, G. And 2 comma negative 6. This is H. Now we draw the figure. Now we're on to analyze. First, the small. Remember that each square has 2, so this is going to be 1, 1, 2, 3. 1, 2, 3. So this is going to be 3 over 3, which is 1, like the m equal 1. Slope is equal 1. Now in this case, 1, 2, 3, 1, 2, 3. So 3 over 3, which slope is also equal 1, and it's positive because it's going up. And since they have the same value, so 3, 3, and 3 and 3, they are also equal. So see if they have the same slope, and they are equal. So they are also parallel because they have the same slope. Now in this case, we have one, wait, 1, 2, 3, 4. Oops, I forgot. So 1, 2, 3, 4, 5, 6, 7, 8, and 10. 1, 2, 3, 4, 5, 6, 7, 8, and 10. So this is 10. This is 10. So the slope is going to be 1, but since it's going down, it will be negative 1. And in this case, it will be 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, I missed something. Yeah, it is 9. Oh, this is also 9. This is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know where the 10 came from. So this is 9. And then here is 1, 2, 3, 4, 5, 6, 7, 8, and 9 as well. So the slope is going to be 9 over 9, which is 1. And since it's going down, it's going to be negative 1. And now as you can see, they are parallel because they have the same slope. And they are also equal because it's going to be 9 over 9 and 9 over 9. So this side is equal and parallel to this side. Now, if we want to know if the lines are perpendicular, we know that the slope needs to be opposite and reciprocal. So a slope of these two little lines is 1, and the slope of these of the big ones is negative 1. Basically, the reciprocal of 1, so 1 over 1 is basically 1, is going to be 1 over 1. They are reciprocal because it's the same number over the same number. And now the opposite unreciprocal is going to be negative 1 over 1, which is basically this, because any number divided by 1 is the same number. So since the slope are 1 and negative 1, they are indeed opposite and reciprocal, so we can say that these angles are right angles. They are 90 degrees. Now, what kind of quadrilateral is EFG? For trapezoid is basically something like this, which at least one side parallel to the other, or which can be something like this, which at least this side parallel to this side. So they fulfill the requirements, but they also have other, like all the sides are parallel. They have also the right angle, so maybe, but maybe not. Now a square, since like you see this side is equal to this side and this side is equal to this side, but they are not all equal, so they can be a square. And because they they will need, like the four side will need to be equal for it to be a square. Now for a rectangle that is not a square, so you can see here the property of a rectangle is that they are opposite and parallel, like the sides or like the opposite sides are parallel and are equal. And as you can see here, this side, the opposite, this side and this side are opposite and like are equal and parallel, and this side are equal and parallel. So it is a rectangle. And as we define it, it is not a square because the four sides are not equal. So this is true. And also the right angles, which is one of the requirements for it to be a square. And now a rhombus that is not a square. A rhombus also requires the four sides to be equal, so this is basically nonsense. And since we have a better response, which is this one, it is also not a trapezoid. Now 40. So in this, I'm going to make this one negative 1, doing -2, doing 1, doing 2, 1, 2, -1, -2. Now, E is 0.5 comma -1, so 0.5 comma -1 is going to be E. I just made the square word 0.5, so it is easy to see it and graph it. Now F is -1 comma 1, which is basically here. So this is F. G 1 comma 1.5, which is going to be here. So this is G. And H 1.5 comma -0.5. Oops, which is here. H. And here I made a mistake. This is -0.5 comma -1, which is going to be here. And E is 1.5. Okay, now it's like correctly graphed. We draw our figure. Oops. And we see, and this is 1, like this 0.5. Like, so this is going to be 0.5, and this is going to be 2. Here is 1, 1, 2, 3, 4. 4 times 0.5 is 2. Like 1 times 0.5 is 0.5. Here, 1, 1, 2, 3, 4. the same. And here is 1, 2, 3, 4, which again is the same. So as you can see, all the sides has the same size. They are as well have the same slope, since the rise here is 2 and the run is 2 and the run is 0.5 and these two they are equal and parallel and the same here and here. They are equal and parallel. Now also the slope, since the slope of this one like FE is going to be rise over run, so 2 over 0.5, which is basically 4, but since it is going down, it will be minus 4. Now the slope of this one's rise over room is going to be 0.5 over 2, which is basically 1 over 4. If we multiply 0.5 by 2 is 1, 2 times 2 is 4. And as you see, this is negative 1 for like negative 4 and this is 1 over 4 positive, so they are opposite and reciprocal. So this is a square, like right a right angle, and since they are also parallel, this is parallel to this, I know this is also going to be a right angle. This is parallel to this, so this is also going to be a right angle and this is also going to be a right angle. So we have this, we have that the four sides are equal, the four sides are parallel to the opposite. We have four right angles. So is quadrilateral EFG kite. Okay, so that's all that apply. So for it to be a kite, we also know that the perpendicular line need to be equal to each other. Like needs to be perpendicular to each other. And by sample size, I know they are going to be, but let's calculate it. This is going to be, I use red. No, I'll use orange. So 1, 2, 3, 4, 5. Wait. I forgot that we are for 0.5. So 1, 2. Never mind. 1, 2, 3, 4, 5. So 5 times 0.5 is 2.5. And then 1, 2, and 3, and 3 times 0.5 is just 1.5. So the slope is rise over room is going to be equal to 2.5 over 1.5, which is the same as 5 over 3. Now in this case, this one is going to be 1, 2, 3, 4, 5. 1, 2, 3. So 5 over 0.5, 2.5, and this is going to be 1.5. So rise over room in this case is going to be 1.5 over 2.5, which is 5 over 3, but it is going down, so this is, wait, 3 over 5. It is going down, so it is negative, so this is negative 3 over 5. And as you can see, they are opposite and reciprocal, so therefore the diagonals are perpendicular to each other. So yes, quadrilateral EFGH is a kite. Now, is quadrilateral EFGH a parallelogram? Well, for it to be a parallelogram, all four sides will must be parallel to each other, like to the opposite. And as we defined it before, this side was parallel to this side, and this one was parallel to this one. So yes, EFGH, it is like a parallelogram. Now, is quadrilateral EFGH a rectangle? Well, the um conditions, the requirements for it to be a rectangle is that the opposite sides are parallel and equal, and that the angles are right. So these four angles are right, so we are good with that. This side is equal and parallel to this side, so okay, we're good with that. And this side is equal and parallel to this side, so yes, it fulfill all the requirements to be a rectangle. Now is quadrilateral EFG a rhombus? Well, for it to be a rhombus, all four sides will need to be equal. Yeah, all four sides are equal. So yes, it is a rhombus. And now is quadrilateral EFGH a square? Um, all sides are equal, the opposite sides are parallel, and all angles are right angles. So it fulfill all the requirements for it to be a square, so it is a square. Now, a quick tip is that if a figure is a square, it is also all of this. Because for if there is a rectangle, the requirement for a rectangle are that the opposite sides are equal and parallel, and that the angles are right. And the requirement for a square is that all sides are equal and parallel. All sides are equal, the opposite sides are parallel, all angles are like right angles, so it fulfill all the requirements for the rectangle, but add one more, that all sides are like equal. So it basically fulfill all the requirements for a rectangle. It doesn't mean that if this figure is a like rhombus, it cannot be anything else. No, like it could be even a square, since all the sides of a rhombus, like the requirement for a rhombus is that all the sides are equal. So the requirement for a square is that all sides are equal plus plus plus. So it fulfill all the requirement for like rhombus. I don't know if you understood this. Please text me, let me know. So I'm trying to go as fast as possible since we are behind. But let's continue now. 41. Imani draws PQR with vertices. She claims that the triangle is as isosceles triangle. Now, let's draw it. I'm going to paste it off. It's going to be miniature, like little, very little. So, okay, wait. Now, 1 comma 1 will be here. And this is P. Negative 2 comma 4 will be here. This is Q. And 1 comma 7. So 1, 2, 3, 4, 5, 6, 7. Going to be here, and this is R. Now she claims that it is an isosceles triangle. Now first, let's see if it is an isosceles triangle, and for that I will say that this is 1, 2, 3, 1, 2, 3, so 3 and 3, and this is 1, 2, 3, and 1, 2, 3, 3 and 3. So yes, these sides are equal, so it is an isosceles triangles in the side like this. They have two sides that are equal. Now, the slope of PQ is 1. Let's see. They all have the slope of PQ, so let's calculate the slope of PQ. Now, the slope of PQ is going to be this. It's going to be rise over room, which is 3 over 3, which is 1. Now, it is going down. It's going down. It's in Since it is going down, its slope must be negative, so it is negative 1. So neither A or B is right, and we can continue our C and D, which is the negative reciprocal of the slope of QR. They two have it. We can say that the slope of QR is 1, which is going to be 3 over 3, and it's going the positive direction. So it is a negative, like the reciprocal, like PQ is a negative reciprocal of QR. And now PQ and QR are equal to, we need to calculate the distance, the longitude of the of the size. Since they are equal, I can use whichever point I like. I'm going to use P and Q. So the distance formula is D equal x1 minus x2 square plus y1 minus y2 square. So this is going to be um -2 minus 1, -2 minus 1 square plus 4 minus 1 square, and this is going to be equal square root of -3 square plus 3 square. So this will be -3 square is going to be 9 positive, since negative times negative is positive, so -3 times -3 is going to be 9, and 3 times 3 is also 9, and so it will be square root of 18. Now, you see, 18 is none of the options. What we can do is basically we can say that the square root of 9 times the square root of 2, which is the same as saying square root of 9 times square root of 2. And we know that the square root of 9 is 3, so we say that 3 the square root of 2. And you see that it is here. It is not a square root of 6. And therefore we know that our answer needs to be D. Now for the next one, quadrilateral has its parts, and which statement about quadrilateral is true. Copy this, paste it. Now we can make it bigger. Are we now? Okay. Now will be 1 comma 3, so 1 comma 3 is R, 4 comma 1 is S, 4 comma 1 is S, 1 comma negative 3 is T, so 1 comma negative T, and negative 2 comma negative 1, and this is U. Withdraw figure. Let's see. Since the diagonals are quadrilateral, so there are two of the diagonals and there are two of the adjacent sides. So let's first see the diagonals. They say that they are congruent and they are not congruent. So first, let me see if they are. Wait, first of all, for wait, no, never mind. So the diagonal here is going to be 1, 2, 3, 4, 5, 6. So this is going to be 6, or t equals 6. Now here going to be US. So US we do need to calculate it. So this is going to be the point. We're going to use the distance formula. Something that you can do is just plug in the distance formula in your calculator. So we have the points are going to be x2 is 4 4 minus 2, so 4 minus is 2, so 4 plus 2 square. This one, the y is 1 minus 1. Let me check if I graph it right. Yeah, 1 minus 1, which is the same as 1 point plus 1 and a square. So we get that our answer is a little bit over 6, so they are not congruent. It is approximately US is approximately 6.3, so they are not congruent. So okay, it says that they are not congruent, but it also says, like, they say that they are congruent, so this is out. When they say that this is not a rectangle, we need to prove that first. And since if the sides are not congruent, the diagonals are not congruent, it doesn't mean it is a rectangle, because I can say this figure, wait, this figure, which is a trapezius, trapezoid, and the diagonals are this, and you see the diagonals are not congruent, but this is a trapezoid. It is not a rectangle. So this is basically like we cannot establish for this single property that it is not a rectangle, so this is out. Oh, as well, wait. Like, wait. I explaining something. I read this wrong. So it says like if the diagonals were congruent, we cannot stable like that it is a rectangle. That's what I wanted to mean. Because in this case, for example, I was right at the beginning. The diagonals are going to be congruent. This diagonal is going to be congruent to this. and this is an isosceles trapezius. So trapezoid. So if the diagonal were going to be congruent, we cannot establish right away that it is going to be like that it is a rectangle. So that's basically what I wanted to mean. Um, so A is wrong. Now for B, the adjacent sides of quadrilateral have equal slopes. The adjacent sides are the ones that are one next to the other, so this side is adjacent to this side. And by simple side, we can see that they don't have equal slope. For they to have equal slope, they will need to be something like this, both, or like this, both in the same direction, and they're basically like this. So they cannot have equal slope. So this is out, and then we have C, D left. The adjacent sides of quadrilateral have equal slopes that are negative reciprocals. Okay. Now, here, negative reciprocals. We know that the slope of this is going to be 1, 2, 3. So rise over room. This is UT. UT is 2 over 3, and since it's going down, it's going to be negative 2 over 3. And for this one, it's going to be 1, 2, 3, 1, 2, 3, 4. So this is going to be rise over room, and this is going to be 4 over 3. Um, it's like, and it's positive, so this is ST. And you see they are not opposite and reciprocal, so this is false. Like they are not opposite and reciprocal, this is false. And finally, we get that A is true. And because one of the requirements for it to be a rectangle is that the like perpendicular lines are equal, but it is not the only requirement. So what I want you to realize with this exercise is basically that if you see, okay, they have equal diagonals, so it must be a rectangle because the diagonals are equal. It's not always going to be like that, but if you see that the diagonals are not equal, then okay, it is not a rectangle because all rectangles like this or like this, okay, this was supposed to be a rectangle. Like this or well, like this, it doesn't matter how the rectangle is. The diagonals are going to be equal, but it doesn't mean that if you see a random figure like this, that was the one I drew before, and the diagonals are equal because in this specific example the diagonals are equal. The figure is like this figure, it is not a rectangle, so it's basically a one-way thing. If you don't understand, please text me and tell me and I'll explain it to you in person. um I think I have time for one more, so I'll do one more. So a rhombus is drawn in the standard XY coordinate plane. The line to x plus y equals 4 includes one of the rhombus diagonals. What is the slope of the other diagonal? Enter your answer in the box below. Okay. Now first, let's see the slope of this line. So I have this and I want 2x plus y equal 4, and I want to leave the y in one side, so I have the y equal, I subtract 2x from both sides, so y equal negative 2x plus 4. And now, since I know that the formula for a line is y equal mx plus b, when m is equal to slope, like m is a slope, and b is the y-intercept, I know that the slope for this line, like the slope of this line is going to be negative 2. Now, it is asking for the slope of the other diagonal. And a rhombus is basically um like any figure that have four equal sides. So this is a rhombus, but this is also a rhombus with all sides are equal, but it doesn't need like necessarily needs to be a square. So this is not a right angle. So well, it's basically a rhombus. And one of the properties of the diagonals of a rhombus is that they are perpendicular. So this is perpendicular, like this line. Oops, wait. This line is perpendicular to this line and forms four right angles. Whatever. So basically, we know that for the two lines to be perpendicular, the slope needs to be opposite and reciprocal. So if this slope is negative 2, then the other slope will need to be opposite, which will need to be positive, and reciprocal just means this is negative 2 over 1. So they will need to be 1 over 2. And the opposite is that it is positive. So the slope of the other diagonal will need to be 1 over 2. Now, okay, I'll do this one as well. Sorry, this has been a little bit long. Since I'm trying to link a little bit faster than I should, I could confuse. I'm sorry. So the 44 is says a line segment has endpoints. Find the equation for the perpendicular bisector of the line segment XY. Perpendicular bisector. So bisector just means that it passes in the middle. And perpendicular is like it is perpendicular. It forms a 90-degree angle. So perpendicular bisector is a perpendicular line that passes in the middle. So I have this. First, we need to find the slope of the perpendicular line. So the slope is just 3 minus 7 over negative 3 minus 5. So 3 minus 7 is negative 4, negative 3 minus negative 5. They have the same sign, so we add them and keep the sign. So 3 plus 5 is 8, and since they are both negative, it's going negative 8. Negative divided by negative is positive, so 4 divided by 8 is 0.5. Positive because they are both negative. Now I have this is basically the same of 1 over 2. I have the slope, but I want to find the perpendicular line, so I know that the slope of the perpendicular line will need to be opposite and reciprocal, so it is positive, and so the slope of the perpendicular line must be negative, and the reciprocal of 1 over 2 is just 2, so the slope will need to be negative 2. Now we know that it is bisector, so I pass through the midpoint of this line, and therefore we need to actually find the midpoint, so midpoint is going to be equal 5 plus minus 3. So it's basically 5 minus 3 divided by 2, comma, 7 plus 3 plus 3 divided by 2. Um, Wait, I put it like this just in case you don't confuse the formula. It's a formula for me pinpoint, so it's 1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So this is going to be 5 minus 3, basically, so it's 2 over 2, comma, 7 plus 3 is 10, so 10 over 2, and this will be 2 over 2 is 1, and 10 over 2 is 5, so 1, comma 5. Now we have the point that we want the line to pass through, and we have the slope, and that's all we need. So basically now to find the equation for this line, um I'm going to do this. Basically, you know the slope formula, it is y2 or y minus y1 over x minus x1 equal m, which is the slope. To find the equation, what we're going to use is what we are going to like multiply both sides by this, and we're going to get that y minus y1 is going to be equal to m x minus x1. And this is the formula we are going to use to find the equation. And it's a very important formula that you're going to even use in calculus when you're taking the college or maybe in high school, whichever you want, like you will like, or if you don't even take it, you're going to use all the way up to the last math level you're going to do. So it's very like it's quite important. What we need to do is like basically substitute the m for the slope and the x1 and y1 for the point we have. So we have the point is our slope is -2 and our point is 1 comma 5. So we have that y minus 5 equal -2 x minus 1. Now y minus 5 equal -2 times x is -2x, -2 times -1, they both are negative, so our result is positive, so it's going to be positive 2, so plus 2. Now we add 5 in both sides, and this cancel out, we get that y equal -2x plus 7, and you see that our options, like the x and the y are both in the same side, so I'm going to add 2x to both sides. This cancel out, and we get that y plus 2x equals 7. And as you can see, is what we have here, and we got the answer. Now, that's all for today. I don't have more time. Don't forget, in Discord, I'm there. You can send message. You can go ask me live. The sessions are generally 5. Well, geometry is generally at 6. It's just that today we all have the free day and I have some things to do at 9. And I asked, like anyone wants a game of like for me to do it at this time. So please go. And that's all. Thank you. Take care. Let's see you next week.